Great seeing you here again. Welcome back to my math survival guide offered to you by the Custer Academy. My name is Luc de Custer, founder of the Custer Academy. And in this fifth lesson, this fifth video related to linear equations, I'm going to describe some specific lines, equations. For example, we will be looking at the vertical, the horizontal, parallel, and perpendicular lines. But before we continue, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. So let's have a look at the content of this video. We're going to look at some special cases, and some special cases that can be very useful later when you will be applying the principles of linear equations. First of all, we have what we call horizontal lines, a line which is horizontal. Then we have a vertical line. The lines are vertical. And we have the parallel lines. And finally, we'll be looking at the perpendicular lines. Let's start with the horizontal lines. And first we'll look at the xy plane, the Cartesian plane, and we draw there a horizontal line. It means the line is parallel with the x-axis. It has one intersection with the y-axis, which is 0b, and the equation is in fact y is equal to b. Whatever value of x we have, the y value will always be equal to b. And that's the definition of a horizontal line. In this case, we can say that the slope is equal to 0, because when we move along the x-axis, the y value will not change. The second element we will be looking at are the vertical lines. A vertical line is a little bit different. We still have the Cartesian plane, but now we have a line which is parallel to the y-axis, the vertical axis. There is one intersection with the x-axis, which is a0, and the equation of this line is x is equal to a. Whatever value we will have, whatever element we will have, it's always x equal to a, and we have all the possible values of y. We cannot select one y value for this specific x value. We can think about the slope, but the slope is not applicable because we have a vertical line and we would divide by 1 and x2, but x1 and x2 are the same, so we would have a 0 in the denominator, which is not applicable for the calculation of the slope. The next element I will be looking at are what we call the parallel lines. Parallel lines are in fact lines in the same x and y graph, which are in fact parallel. They basically have the equation y is m1x plus k1 with the y-intercept k1, and the second line has the equation y is m2x plus k2 with the y-intercept k2. Lines are parallel when the slopes are the same. So in this case, for those two equations to be parallel, it means that they have the same slope, and we could write the equation of the second line, the top line, y is m1x plus k2. So the slope element is always the same for parallel lines. The last remaining example are the perpendicular lines, and now we're going again to the x and y system, and we have now the red and the green line, which are perpendicular. The equations are, for the red line, y is m1x plus k1. We have the y-intercept k1. For the green line, we have the equation y is m2x plus k2 with the y-intercept k2. And when we look at those, the angle between those two lines is 90 degrees. It means that they are perpendicular to each other. When we look at this, we can prove that the condition for perpendicularity is in fact that the product of the two slopes m1 and m2 is equal to minus 1. We can also express m1 as a function of m2, and we can say in this case that m1 is equal to minus 1 divided by m2, and reciprocally we can also say that m2 is equal to minus 1 divided by m1. So that's it for all these different special lines that we can encounter in the linear equations. That's it for this video. Don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. Thank you very much, and I'm looking forward to seeing you in our next videos. Bye bye.